Hey friends, welcome to today's Bellringer. Now, a few of you have asked me, Miss Lynn, why is there student work included in the slide that goes with this problem? And I'm going to explain why I included that. Today, this Bellringer is a little bit different from our usual assignment. We're going to go ahead and work this problem here. Okay, let's go ahead and read the problem. Nora is riding her bicycle on a trail that is 18 and 5/10 miles long, and she's already ridden 7 and 36/100 miles of the trail. So if you picture her destination on a map, she's started at point A and she's going to point B. And the total distance that she's going to be on her bicycle for is 18.5 miles, which of course we know 18.5 is 18 and a half. And she's already gotten to about, a little less than halfway. She's gotten to 7 and 36/100 of a mile. Question A tells us to write an equation that can be used to find M, the number of miles she has left to complete on the trail. So this is a little bit of algebra that they're asking us to do. So we need to label part A, and we're trying to find M. So I'm going to put M equals, and then I need to think about how can I fill in an expression. I need two number values. I'll have a number value right here, and I'll have a number value right here, and then I'll have an operation right here, either addition or subtraction. So first thing I guess I have to figure out is what operation I'm doing, addition or subtraction. Let's look back at the instructions. We're writing an equation that can be used to find M, the number of miles Nora has left to complete on the trail. So I'm going to take the total number of miles that she has to go, and I'm going to subtract. If I can erase my little box that I made here. Oh, it won't let me. Okay. I'm going to subtract 7 and 36/100 of a mile. And then my answer is going to be M, the miles she has left to complete. Okay. Another way of doing this, if you wanted to be fancy, is you could take the portion that she's gone so far, which is 7 and 36/100, and then you could add M, which is the distance she has left to go, and that would equal all together 18 and a half miles. So two different ways to do this. Part B, let me make sure I'm labeling the parts of my question. Use your equation from part A to find the total number of miles Nora has left to complete on the trail and show your work. Use your equation from part A to find the total number of miles. Oh, so I have to actually solve it. Is that right? Yeah. Okay, so I'm going to take M equals 18, typo. M equals 18 and a half minus, it's going to be easier for me just to do it like this, 7.36, and I'm going to put a 0 here as a placeholder because I know with subtraction I have to line up all my numbers by place value. Okay. 10 minus 6 is 4. 4 minus 3 is 1. Drop down your decimal point. 8 minus 7 is 1, and 1 minus 0 is 1. So I've got 11 and 14/100 of a mile left to go. Okay, let me just draw a squiggly line here so I have room for part C. How many more miles would Nora ride before she takes a break? Oh no, sorry, I skipped something. Hold on, let me go back up. Nora wants to ride half the number of miles she has left and then take a break. Okay, gotcha. So she's going to go halfway, 1/2 of the distance. And then this is going to be her breaking point where she stops. Okay, So I'm going to do 11 and 14 hundredths of a mile. And I'm going to divide that in half. And then my quotient will be when she gets to take her break. Okay, so let's see. 2 goes into 11 5 times. Let's see. Divide, multiply, subtract, compare, bring down, and then repeat. So I did my division. 5 times 2 is 10. Now I can subtract. 11 minus 10 is 1. Compare. 1 is smaller than 2, so I know I'm on the right track. Bring down. Bring down the 1. 2 goes into 11 5 times. 5 times 2 is 10. Okay. 11 minus 10 is 1. 1 is less than 2. Bring down my 4. And then 2 goes into 14 7 times. 7 times 2 is 14, so I have no remainder. That's a good thing. Okay, so now when I'm deciding where to put my decimal point, I can either think about what makes sense here. If she's going about 12 miles, what's half of 12? 6. So it would make sense that my decimal point would go here because I could round 5 and 57 hundredths of a mile to about 6. And then the other way I know that I'm right is because my decimal point should just go straight up and land right in the same position, but just one layer up. So the answer for C is 5 and 57 hundredths of a mile. She will go 5 and 57 hundredths miles before taking a break. All right, now, if you're wondering what all of this has to do with, and then we're going to take a look at this student's work. This is a random student from the state of Massachusetts who answered this question. We're going to take a look at this student's work and decide what is good about it, and maybe see if we can use her work and the example that I show you to come up with a list of things that we're going to try to do when we're answering this type of question in the future. So this problem is going to kind of be the introduction for our live lesson one day next week. This girl's work. The answer is, I want you to take a look at what she did, what her work is. I want you to decide if her work is correct or incorrect. And I want you to make a list, maybe like up here, of 3 things you think she did well. If you were to give her a grade for this, what positive comments would you give her? 3 things that she did a good job with. All right, let me know if you have any questions about this, but that's your bell ringer for today.